Hello guys, today we will evaluate the integral proposed in the Romanian mathematical magazine, where equals to integral from 0 to plus infinity of 1 over square root of n plus exponential power pi over square root of x, all multiplied by dx over square root of x cubed. So let's start. We will begin by taking this term as the change of variable. So let u equals to pi over square root of x. Then du will be the derivative of this term dx, which is minus pi over 2 square root of x cubed dx. Then multiplying du and this term by minus 2 over pi, we get minus du multiplied by 2 over pi equals to dx over square root of x cubed. So instead of dx in the integral, we will put minus 2 over pi du. Now let's check the new bounds. For x equals to 0, then u will be pi over 0, which is plus infinity. And for x equals to plus infinity, then u becomes pi over plus infinity, which is 0. Then we get I equals to, the new bounds are plus infinity and 0. Here we have 1 over square root of n plus exponential power. This term is u. And instead of dx over square root of x cubed, we get minus 2 over pi du. Then I becomes 2 over pi integral. We will change the order of this integration by cancelling the negative sign. So 2 over pi multiplied by integral from 0 to plus infinity of 1 over square root of n plus exponential power u du. Now let's change the variable for another time. We will take this denominator as a new change of variable. So let z equals to square root of n plus exponential u. So z square will be n plus e power u, and so derivative of this term 2z dz equals to derivative of this term, which is e power u du. Then we get dz equals to e power u over 2z du. But e power u from this equation equals to z square minus n. So dz equals to z square minus n over 2z du. And so we get du will be this term multiplied by dz over this term. So du will be 2z over z square minus n dz. For the bounds we have, if u equals to 0, then z will be square root of n plus e power 0, which is 1, which is the square root of n plus 1. And for u equals to plus infinity, then z will be square root of n plus e power plus infinity, which is plus infinity. So I becomes, here the new bounds are square root of n plus 1 and plus infinity. 1 over this term is z, so we have here z. Du is equal to 2z all over z square minus n. So here we have I equals to 2 over pi. This is equal and not the negative sign. So here we can cancel out z and z to get I equals to 2 over pi integral from square root of n plus 1 to plus infinity of 2 all over z square minus n. By factorizing the denominator, we get 2 over z minus square root of n, all multiplied by z plus square root of n. Now we have to work with this term. We can use the method of partial fractions, but we will use another method. So 2 over pi here. Here we have 2. Then we will multiply square root of n here and square root of n here. So we will get 2 multiplied by square root of n, which is square root of n plus square root of n. We will add z and then subtract z. So we will have here z plus the square root of n minus z minus square root of n. So I becomes 2 over pi square root of n, z plus square root of n minus z minus square root of n all over the denominator dz. Now we have this term over the denominator. We can cancel out this term and this term. So we will have 1 over z minus square root of n. Similarly for this term, we will have 1 over z plus square root of n. This integral is equal to ln of z minus square root of n, which is du over u. and this term is equal to ln of z plus square root of n. Here we have ln a minus ln b, which is ln of a over b. So I becomes 2 over pi multiplied by square root of n all into ln of z minus square root of n all over z plus square root of n from plus infinity to square root of n plus 1. So instead of plus infinity, we can put a and put limit as a tends to plus infinity of this term. So I becomes 2 over pi over square root of n. First, we have the limit, and second, we will substitute the square root of n plus 1. Limit of this term is equal to ln of infinity over infinity, which is indeterminate form. So we will take a and a. So it will be ln of a over a, which is ln 1 and equals to 0. Here, substituting square root of n plus 1 and here square root of n plus 1, we will get minus ln over etc. So I becomes 2 over pi of square root of 2. Here we have ln 1 is 0, and then this term will be remaining. So I equals to 2 over pi square root of n into minus ln of this term. We can exchange the numerator and denominator and cancel out negative sign, because ln of a over b is equal to minus ln b over a. So I becomes 2 over pi square root of n ln of square root of n plus 1 plus square root of n all over square root of n plus 1 minus square root of n. We can stop here, but we can also continue and make this form more easier. So we can multiply by the conjugates. So we will get 2 over pi square root of n. This term multiplied by this term, which is all square. And here we have a minus b multiplied by a plus b. Here is a plus and not minus. So we have this quantity square minus square root of n square, which is n plus 1 minus n. So n and n will cancel each other. So we will have I equals to 2 over pi square root of n ln of square root of n plus 1 plus square root of n all square. We can take the square next to ln here to get 4 over pi square root of n ln of square root of n plus 1 plus square root of n. But we know that inverse sine hyperbolic of x equals to ln of x plus square root of x squared plus 1. Instead of x, we will substitute square root of n. So we will get sine hyperbolic inverse of square root of n equals to ln of square root of n plus square root of n plus 1. So instead of this term, we will put inverse sine hyperbolic of square root of n. Therefore, this integral I equals to 4 over pi all multiplied by inverse sine hyperbolic of square root of n all over square root of n. Thank you for your watching.